Hello YouTube. Today I want to show you how to make a threaded C# server application. I've been learning this myself a bit because I couldn't really find good examples on the internet. Now there are, but I kind of learned it myself. So I thought I should teach the other guys who don't know yet how to do it. So here's my tutorial for it. I'm just going to create a console application because that's easier to work with, and I'm going to call this one threaded server. So, first thing I'd like to do is just make a listener. So I create a new class called server and make the basic server properties in here. Make this public. Add a public integer port, the port I want to use, and make it a property, and also capitalize this. Then a constructor, and just assign it. So there's a basic constructor and properties. Then I prefer a separate starting function separate from the constructor. I also put the TCP include system.net and TCP listener here. Oh, it's .sockets. Yes, there we go. Okay, and I prefer to make a separate starting function, so public void start. You do here, you assign something to listener, of course. So listener is new listener, and this one is deprecated. It doesn't say it right here, but it actually is. Like when you port, it was given error like this is obsolete, so you have to use an IP endpoint. So the easiest way to just accept from all ports is new IP endpoint, which is actually in system.net. IP endpoint, and just use IP address.any, and then the port you use. So there you go. Now you have a listener. Next up, you want to start listener, and it's easier to make a separate loop for it to listen. So you just public void, well, actually makes private void listener. Import threading. Oh, this is that one right there. So you just start a new thread. And it's actually a bit better to put that one here. Private listener thread. And call this one listener thread. This way you can close it when you want to close the program or something. So now when you have like public void stop, you can do listener thread dot abort or something. And then in listener you want to do just a loop that just listens forever. I like to try catches actually, because sometimes it might give derpy stuff. You don't want that. So I'll just make a listener here. You want to listen for TCP clients, so separate clients that are going to connect to you. Is listener accept TCP client, and what this basically does, it just waits here, so it just sits here waiting until a TCP client connects to the port, and then it will continue. And then you want to start a new thread, but I'm not going to do that right now. Well, actually I could make a function for that. So private void handle client, And you can handle the clients like so, new thread. You don't really need to save those threads actually. Well, except if you're going to make like a streaming connection, so if you're going to keep the connection open, then it's better to save the thread like up here or like in an array or something. But for this example, I'm just going to connect, then ask for something and get a reply and then disconnect again, so it's not really necessary to save the threads. So I'm going to make a new thread start. This is a simple trick I usually use. You can use a what was it? Thread parameter. Yeah, this one. You can use a parameterized thread start for this, and then start it later. But I like to use just like thread start, and then like so. Handle client. Start. It's a simple trick. It works just the same. Oh, and this has to be C. So this way you can like handle packets right here. So you could make a whole packet class for that, or just like read the first bytes and handle them right here. Well, at least if you're going to use like packet IDs, which I usually do. So how I would approach that, like byte B is client that get stream, reads bytes. Actually reads out an integer, but you can just call that to a byte or something. And then you just like, we'll actually put an error message here. So then you have to message of what's going wrong there. Okay, back to the handle client function. I usually read like the first byte or first 2 bytes if I want to make like a lot of packets. So with 2 bytes you can make a short value. Like if I were to like bytes packet ID data is new byte 2, and then client get stream read packets data packets ID data 0 2, and I'd read like 2 what's wrong here? Oh, packet ID data. Then I'd read like 2 bytes from the stream, and you can convert that to a short packet ID like so, bit converter dot to integer 16 and packet ID data 0, just for start index. Or actually ushort is like better because you can go up. Ushort is from 0 to 65,000 I believe. Is it? Oh, can't see that. Well, but then you have the packet ID you want to receive, and then you can just make like an easy switch packet ID save some space there. Switch packet ID, and then just case like what happens if it's packet ID 0, etc. Like so for example, if you want to make read out a string, which I usually do like this, I start with a 4 bytes prefix of every string with its length in as an integer value. So I'd read out an integer first. It's actually easier to make functions for reading those values, but because this is a really small program, I don't really need them right now. But I'll put some functions for that in the description if you like. So then it's easiest to get stream read data 0 and just 4. Oh, yes, and then you can convert that to data is. Well, actually, no, not to save. Integer length is bit converter dot to integer 32, and then data again, and then 0, and then you have the length of the string you want to read. So data is new byte length instead of 4, and now you can just read the rest of the data you need. length and console write line encoding ASCII get string data. And then I like to do like a like that with some fancy characters around it. You could expand this to a lot of packets, or even even neither would be to like have a packet class and handle every packet with its own class or with a huge class for packets. But I think that's yeah, each packet its own class is a bit tidier. And you can also send data back if you want. So you could like send. I have to do this with a list actually. List byte back data is new list byte. Back data dot add. Just add the packet ID, so that's 0. Back data dot add range. Actually, first make a string we want to send. String response is successfully received data. So then you want like converter to, you want to add like the prefix of the string for its length, and I usually like to do it like this. Get byte count response, and then after that you can just directly add the string to it. Oh, get bytes response. Make sure when you're using this get byte count function that you're using the same encoding as that you're actually sending it with, because I think it's Big Endian and I think Unicode too. They use more bytes per character, I believe. I think they use 2 instead of 1. So, and then you just have this array, and you can just send that back to the client that's connecting. So right, back data to array 0, back data to array length, or count or 2, but whatever. And then at the end of this you want to close the connection, otherwise not connect. Close connection, just to make sure that nothing's still connected or something. So here's a basic client handler for just one packet. I'll go over it one more time. Oh, and I still have to make this function here. You first have to make a server instance, so I'll do that right now actually. It's a bit clearer. Server is new server 1 2 3 4 5. Actually, no, if that's like probably not. Server.start, you can just start a server immediately, and you don't really have to. You could like do a read key here or something, or like this, to prevent it from closing the application, but you don't really have to do that because this server start is launching a new thread here, and because of that, this program won't stop until all the threads are stopped. So you could, what you could do is make a read key here. I like to do it like this. Just read the key from the console, and then make a single key to shut down the whole server, to stop the server. So if c.key yes is console key q server.stop, and then when you call server.stop, it will only stop this listener thread right here, but it might still have a handling client thread here, but it will just finish that one, and then after that's finished it will then finally all threads are stopped. So it will just continue with the main thread, and after that we can actually return this main thread too. I think that works. So I Actually, I want to make this port input, and then I want to like display that started server on port. So you could actually start this, and it should like already work. And this, you always have to do this the first time you launch your program. Well, at least on Windows 7, as far as I know. So here's the server is now running. Oh, it's a bit slow. It's now running on port 12345, and when I press Q, it shoots. No, it's not. Well, that's a great example. Is it? Oh, wait a minute. Closing server. It's supporting listener thread, which should stop this one here. It's weird. Okay, so here I am again. Sorry for waiting. So what I just forgot to add was like listener.stop. It's one line actually. And I added a line here so it displays the packet ID. Packet ID received. There are better ways to like stop and start a server with I think it's begin accept TCP client and begin accept socket. Listener dot begin, yeah, begin accept TCP client. That's it's a bit better with thread safeness, but this one does just work, so I prefer using this one. So here's the server. Now to make a quick demo of a client. Yeah, just make clients quickly. New project. Threaded server client test. I can actually make multiple clients at once, so I'll just make a client class for that. Client public int port public string IP. I'll just do it like this. Public void connect. Public void send payload. Well, actually, string get payload answer. String payload. Actually, make the functions here too for the integer to byte array and byte array to integer, and same for string and bytes. So private byte make int is quite easy. It's just like return bit converter dot get bytes. I will just return for bytes, then private string private by make string input list. This one is a bit harder because it's it has to have a prefix of the integer, so I usually do it like this: data add range make int input length. Well, actually get byte counts input data add range encoding ASCII get bytes input and return data to array, and then backwards private int read integer. It's actually easier to do a TCP client in here. Fix the imports using system threading. I don't really need it actually. Using system dot net using system dot that's sockets, that one. Client. I prefer using it like this, so then you have like a byte. Integer is just 4 bytes. Byte data is new byte. 4 client gets through. Gets stream read data 0 4. Keeps doing this. 4 and then return bit converter dot 2 int 32 and then data 0. And then for string, private string, read string, TCP client, byte data is new byte, and then the integer prefix, and then client that gets string reads data 0 data length. Make sure to do like data length here and not another read integer client. I once did that, and that's going to read a integer twice, and that's going to mess up your whole streaming thing. It's quite easy to understand why that will fail, but I didn't at first. And then return encoding ASCII get get string data. So there's a few simple functions for that. Now when I want to send like a private TCP client here, so I would make new client connect IP port clients get string write, and then I'll make a payload first. Payload bytes is make, actually no, list byte payload data is new payload data add 0, wait no, add range, because it's a short, so it's not a byte. So I'll add a short of 0. I think when you do just 0, it will think it's an integer or something. So you have to make sure you put short in front of this. So we'll just use it 2 bytes and not a 4 for integer. Then payload data dot add range make string payload, and then this should do it. Payload data 0 payload data count, I think. Yeah, that will just work too. And now to payload data to array here, because it has to have a byte array and not a list. This is a, yeah, okay. And then to read the data again, we just do string answer is read string. That's why those functions are so handy. Just pass in the client and then you're done. And then you just return answer. Or you could like return here, but anyways, so this is a test client setup, and I'll just make a few clients here. So client, I'll just make an array of 5 or something. Clients is new client for integer is nil. Is client's length I plus plus. Clients I connect, which is all connect to the host, and then when they're all connected, I'm going to send all of their requests. So this way they're all this way the server won't have to like connect and then handle packet and then disconnect again and handle the next one, but this will actually test if it's a threaded server or not, because now it's going to have multiple connections at once. It all has to answer. So client sends clients gets payload answer, and we'll just make a string payloads. This new string 5 hello world, hello router, hello everyone, YouTube and me gusta. And actually, this thing there. And is this not working? Oh, I forgot it. Come on there. And it works. So get payload, answer payloads. So now every client index 0 is going to send hello world. It's pretty obvious, I think. And then it's just going to string answer is sent. Yeah, I'll just do this one. Send this, and then console write line received, and then we do answer, and here we do payloads I, and then we don't want to like whoa, we don't want to like quit this application at the beginning, so we do console not constant console read key true. So make sure we start the threaded server. It's listening at port 1, 2, 3, 4, 5. Oh, I actually have to make each client's I port is 1, 3, 4, 5, and client's IP is, I think that will do. And then we start this one, and of course we have to initialize them first. Client I is new client. Makes sense. And here you go. So it received hello world, hello router, hello everyone, YouTube, and me gusta. And that was actually done by it's receiving some wrong data, I think. Did I really do? Oh, wait a minute. I didn't really take into account that I'm reading. I have to straight the first 4 bytes off, because I'm actually reading the packet ID first. Oh, that's actually 2 bytes. So get stream just reads, and then new byte 202, and you could check this and like make a new byte array and check if it's actually 0, but I'll just assume that it's correct. So I'm just going to read 2 bytes from it, and I think out of memory exception. I did something wrong. Receive data. Did I add range? It adds a 0. That's wrong. It should be add range. Bit converter dot get bytes short 0. Another. So forgot that. It has to be short. Oh, and then we pull this to the right. We start this one, and now it's working correctly. Finally. So as you can see, it's as I did here. Whoa, as I did up here. I first connected all clients, so it actually went through the accept TCP client function and made a new thread for each one of them. And then when that was done, so it just had 5 running functions of this one. And then after that I just sent all the data, so it was actually just idling right here, waiting for packet data to receive. And then it continued each thread of that. So here's the output of the server. Alright, here's the output of the client, and this is server. And there you go. I hope you liked my tutorial, and if you have any suggestions, just leave them in the comment section. Thanks for watching.